right, guys, long day, but geez, there's a lot of people here. All right, guys, look, we're gonna get straight into it because I know we got less than about 12 hours or 13 hours that's left before you guys head back into your exams. So, as I mentioned before, we are going to be covering some really quick, um, well, basically just covering all three of those equations with three graphs, basically exponentials, parabolas, and straight lines as well. I'm just going to run down real quickly, guys, because I understand that it is kind of last minute for a lot of people, and really, I'm not going to lie, I can't actually keep up with the comments. I can't even read it. It's just like just going crazy. So I'm just going to have to ignore it at the moment, and I might actually get in at some point just to see if I can help out somebody. All right, so we're going to get straight into it today, and kind of quick summary of things that you're going to need for TEG, which is tables, equations, and graphs. Now, in this session, I don't think I'm going to have time to cover geometric reasoning, and I know I'm not going to be able to cover any kind of what do you call it? A chance and data, definitely. All right, that's just not my territory. By the way, just real quickly, and I know there's a few level 2 students hanging around here. I've just trying to get my hands on the paper, and maybe I'll get back to you guys and talk to you guys later about the level 2 paper. As for the level 3 guys, I will see you guys on Sunday. Just yeah, because it's Monday exam, right? Cool. So let's get straight into it. Just like a quick revision of everything that you guys need to know. We're going to run down with straight lines first. All right, and then what we'll do is like 20 minutes in, we'll go through quickly with what you need to know for quadratics, and then 20 minutes in, we will actually go into exponentials, and I'm hoping to be done by 9:45. Yes, I know that doesn't add up to considering we only started this time. Cool, guys. So I know a lot of people actually ask me this question is like, is my graphics calculator useful for this paper? Massively, massively useful. If you do not have a graphics calculator, you can still kind of get through this paper, but it just means that it requires you to do a little bit more algebra. But as for the graphics calculator, especially for those guys that are doing geometric reasoning, one of the biggest tips that I can give you guys is this. Make sure that you actually, when you reset your calculator, what happens is your calculator angle right there goes into radians. All right, so really, really important that you guys actually change that to degrees before you start doing your geometric reasoning, if you are doing geometry. All right, so that's just a real quick tip there, just making sure that you click on Shift, Setup, go down to Angle, and change it from radians to degrees, because you guys will be asked to actually reset your calculators, and when you reset your calculators, it actually goes into that other mode. Okay, so going into straight lines, look, if in doubt, I always say this, remember these things, all right? You've got your y equals mx plus c, and let's say you know off the top of your head, like you're like struggling to even kind of try and put those two things together. Basically, the m, that ends up being like your slope, your c is ends up being your y-intercept, all right? So that is, if we're looking at a line like this, let's say we got something like this, that value right here, this value here, is known as the c value, all right? And then what we have got is we've got the gradient. So the gradient ends up being the slope. Now, a lot of people would have done this in like different ways. Like you might actually have rise over run, where you look at the difference of how much it's actually risen from one point to another point, and also how much are you going along the x-axis. All right. Now, some people might be super comfortable with using something like this, like change in y divided by change in x as well. So there's actually lots of ways of doing this. So if you know a particular method and you are actually comfortable with it, then just stick to it. All right. Like you don't need to like learn something new right now. So if you know how to find the gradient and if you know how to find the y-intercept, then stick to it. Okay, so you don't need to do anything different. Now, if for any reason you're the type of person that's like, oh, but I've been using the graphics calculator all the time, remember this: with the graphics calculator, you want to have 2 points for equation of a straight line. So let's say, I'm going to do a quick example here so that we can kind of see both ways. So let's say we got something like this. We got a point there. Let's call it 10 and 15. And that one there, we're going to call it 25 and what are we going to go with that? I don't know, 50? Yeah, let's go 50. Maybe I'll just do an easy one today just so that we don't actually mess up things. So let's go 60. All right. So in this case, you want to work out the equation. Now I'm going to do the first method, which is like just going straight through the calculator. So if you have a graphics calculator, click on menu, and the mode you're looking at is stab mode. So click on stab mode and put in those 2 values. All right. Now what you're going to do is you're going to put your x values in list 1 and y values in list 2. So all I'm going to do is 10, and I'm going to put down 25 because those are my x values. Then we got 15 and 60. Holy moly, 801. Jesus, this is just crazy. Right, anyway, so once we get those 2 points, just click on graph 1, and there's your 2 points in your graphics calculator. You click on calc, and this is the one that you want for your straight line. All right, now the good thing is, like with graphics calculator, it just gives you the equation, so you just write it down. In this case, you can see that it says a is 3 and negative 15. Basically, that just means that your gradient is positive 3 and your y-intercept is negative 15. So our equation is y equals 3x minus 15. All right, so that's with a graphics calculator. All right, now you're the type of person that does not have a graphics calculator, and you're like maybe going, geez, how do I do something like this without a graphics calculator? Really simple is this. Have a look at, and I recommend you guys to do this as well, is like grab a highlighter. A highlighter always helps you to see things a little differently. So I grab my highlighter here, and I'm just going to highlight the y values first. Then I'm going to highlight the x values. All right, basically what I'm looking at is my rise, which is the how much is it rising by, and then my run, which is that green line there. So if I look at it as units there, that yellow line, I'm actually doing 60 minus 15 to get 45. And the green line, the full green line, is going to be 25 take away 10, which actually gives me 15. And what I can do is, so remember that the gradient is how much is it, like you can actually say it's rise over run. So in this case, you can say that it's 45 over 15, which is 3. All right, so as you guys can see, you can still do this without a graphics calculator. All right, so you can just work out the gradient on its own. And then once you get the gradient, now it's time to work out the actual equation. So we can go back and just write down y equals mx plus c. And you can choose either point. All right, you can choose 25, 60, or you can choose 10, 15. It doesn't matter which one you choose. Let's say I'm going to choose 25, 60. Then all it is just I'm just substituting it in. So I've got 60, which is the y value. M is equal to 3. X is 25, and plus c. So if I rearrange this, I'm going to get 60 equals 75 plus c. And c is 60 minus 75. Now this ends up giving me minus 15 equals to c. So as you guys can see, that basically it is the same 2 equations that you get. So you can actually do this without a graphics calculator, but it just means that you got a little bit more work. Yeah, now I've completely just, I can't even I can't even read a comment. By the time I read like one word, it's gone. So so how do you? I actually found a question. How do you find the gradient? To find the gradient, it's this process right here. All right, just rise over run, or looking at how much has the y changed by, and then how much has x divided by how much is x changing by. So cool. So that's one kind of idea with straight lines. The other things that I've seen pop up with the straight line, or like not straight line graphs, like you guys might have seen the whole flat lines with like colored holes and open hole kind of questions. And I'm going to give you guys a really quick example, and it just kind of gives you an idea of how this actually works. So basically, take the situation here. So I mean, like I used to use this in my class back in the day, but basically it's still valid. You know, went to a movers company, and they basically said that, look, how much do you guys charge for you guys to move? And they basically said, oh, we charge $50 per hour. All right, for the first hour, it's $50. I think it was 50. No, I think first hour was 150. And then after that, every half hour, after the first hour, every half hour was $50. So to kind of to put it into perspective, if I was going to actually draw this as a graph, okay, if I was going to draw this as a graph, then what I need to do is I need to think about time and how much how much money is actually it's going to transfer over, right? That's what I'm trying to do. So, and again, like, look, people will always contest me on this one because they'll be like, oh, what if it's like 1 second over or 1 second under? And I guess that's just where like the semantics happen. But anyway, on our x-axis, we're going to put our time. And on our y-axis, we're going to put our cost that's going to cost us, right? So for the first hour, so that's between 0 and 1 hour, he's going to charge us $150. So that means at 0, he really should not be charging me anything. So let's say I'm going to go 100. This is like terrible diagrams at this roughly, but you guys get the idea. What's going to happen is it's going to be an empty hole, because like really he shouldn't be charging me any money for 0 minutes. But again, you could put it as a dot covered one as well. But basically, what's going to happen is after 1 hour, he is going to charge me $150. But anything between 1 hour and 1.5 hours, what's going to happen is we've got a little hole that comes up, and it's going to get blocked out at 1.5 hours. All right, because at 1.5 hours, we are paying $200. But what happens is the next thing is at 250. So that's going to open up. So by the end of 2 hours, you should have actually paid $250. Yeah, $250, because that's 150, and then that's roughly $250. All right, so that's pretty useful to kind of know, especially with these kind of questions. The other question sometimes they do is like, just because you join like you might get questions where like at the end of each week they get this much money. What happens with those cases is like, just make sure that they're actually, you put it as a dot and not like a joint line. So say, for example, I think this was in last year's exam paper where it was like, okay, so this person this person is saving this much money by the end of week 1, week 2, and so on. So if that's the case, then you always put it as a dot. So you don't actually just join the line up, because they get paid at the end of each week. Voice is gone. Voice is gone. All right, so that was kind of like really quick idea on sure, Jules, I got that covered. Yeah, so this is basically the step graph that's actually quite useful. It's handy to actually have as well. The white dots, Mila, basically means that there's actually no value in that. So we don't. It's called like it's an empty one. So there should be nothing in there. So you can basically say at 1 hour you're going to actually get paid $150, but at 1.5 hours you're going to get paid $200. So it doesn't matter whether you get paid like even if the guy only works for an hour and 15 minutes, I still got to pay. I should say every half hour there. My bad. Every half hour he's charging me $50. All right. Look, basically what we're going to do is that's just like a really brief little summary of straight lines. For you guys, it's just going back. When you get remember your questions are going to be set up in a way where they have straight lines, they have parabolas, and then they have exponentials. So you see a straight line, get a gradient, get a y-intercept, get the equation down, and that should actually help you out. So the reason the dot is actually closed at 1.5 hours is because at 1.5 hours, he can only charge me $200. He shouldn't be charging me $300 just because he worked 1.5 hours. So for the first hour, he's getting $150, and then after that, every half hour, he's adding $50 extra. Yeah, cool. So let's head over to parabolas. So quick summary of parabolas. Now, I don't remember doing this. I don't know if this is going to work, but let me just quickly check. Nah, it doesn't work. Yeah, no, I thought you could actually do this, but no, you can't do it. That's fine. So, quick summary of parabolas. All right. So once again, I'm not going to spend time doing the long method of a parabola, but I will give you guys one little hint that should help you. If you're really stuck and you don't have a graphics calculator and you're like, oh man, I really just need to know how to do this. I saw a question pop up with the asymptote. We'll talk about that when we get to exponentials. All right. With parabola, what we have is that right there is the vertex, right? Now, parabola has 3 different forms. I'm going to write that down first, and I'm going to need some water. Give me a second, guys. I need to get some water. I'm dying here. All right, so what we have is there's actually 3 ways in which you can write the parabola, right? But the problem is your calculator ends up giving this, that formula there. The vertex one is like pretty easy to do if you know a couple of tricks, and I'll do one like real quickly with the vertex one so that you guys can actually see how it can be done. So let's say we've got this. Something like this. We got this. All right. The good thing about vertex is that you only need the vertex and another point to come up with the equation of the parabola. Because if you were given this particular points, then to try and do this on a graphics calculator, you need a third point. So with the graphics calculator, you actually need 3 points to get the equation of the graph. But with vertex form, it's just the vertex and one other point. So how do we do this is this. And again, your teachers might have explained it to you in a completely different way. And I'm not saying that they're wrong and I'm right. It's just people have different ways of writing this particular formula. So my kind of thinking behind this is that this letter ends up being this value, and this letter ends up being this value from the vertex. So our equation is x minus 5 squared plus 7. And at this point, we've got to try and figure out what the a value is. So to figure out the a value, we are going to substitute 15 and 8. 8 and 15 to figure out what the a value is. And where we're going to do it is that the 8 ends up going here, and the 15 ends up here. And when we rearrange it, we can actually figure out what a is. So we got 15 equals a, 8 minus 5 squared plus 7. So 15 take away 7. A is times 3 squared, and what we've got is 9a, 8, and a equals 8 over 9. So the equation is 8 over 9 x minus 5 squared plus 7. So you can, that's basically in the vertex form. And you know, you can actually give your answer in vertex form, you can give it in intercept form, but in this case, because we don't actually have any intercepts, or we can't actually do it in what do you call it, in vertex form. Sorry, I know I saw a couple of questions there. How would we know which number goes where though? Harry, that's one of the reasons why I kind of just highlighted things there so you can actually see where the numbers go in terms of substituting it. Yeah, after the live stream, this will get saved, guys. Rahul, when you use step graph is like the connecting a straight line is usually like when on the x-axis you're looking at you know, it's basically, it's kind of saying like man, Jesus, voice is killing me. But I'm gonna go back to the question, Rahul. So when you have like days, for example, if they're getting paid by days, then you could potentially put that as step graphs. But again, it depends on the situation. So you've got to look at the situation and go, and I'm going to go back to the question that we did in 2019. You know, how she saved the money at the end of each week. So in the middle of the week, she wasn't getting any money. So that means it has to be a step graph. But if I say I'm working in my job and I'm getting paid $15 an hour. And that means if I work half an hour, I'm going to get half of that $15. So that in that case, it'll be a straight line, because I could actually get paid for 1.5 hours if I work, or 1 hour and 45 minutes. So it really depends on the situation. So you got to look at the situation and go, is this a situation where are they going to get paid consistently, so it's actually going up like in a straight line, or is it like going to be flat? The A value basically just makes the parabola go skinny or wider. That's pretty much. And if it goes negative, then it's going to be upside down. I'm actually going to do the same question here with a graphics calculator. So what happens if you are given only 2 points and you got to use a graphics calculator? What you can do is you can use line of symmetry, because notice how this is like 5 and 7. So if I was to reflect that point, this point here basically will become 15, and it should become 215. The reason I got that 2 is because from here to here it's 3. So if I go backwards 3, I'm actually going to get the x value, which is 215. So now that I got those 3 points, I can go into the graphics calculator and chuck it in. So I've got 2, and I've got 5, and I've got 8. So we got 15, 7, 15, and I'm going to just do the whole thing with x squared and pretty much get this ugly looking number here, but that's fine. That's absolutely fine, because that's what you're getting as the equation here as well. Yep, I'm going to go next into translating graphs. Translating graphs, just give me 1 second. I just want to pull up my like literal summary of notes in one shot. Nah, I can just do it, it's fine. Okay, for the translation of the graphs, this would work for all 3 graphs. All right, so if you have it as and because we've done just straight lines now, but I'm going to show the parabola first. So if you have x minus h squared plus v, or you have y equals, all right, so this is the 3 different formats you have for your parabolas, right? So what's going to happen is this. The first thing is moving up the graph. So if we actually move up the graph, what's going to happen? If I move up by 5 units, all right, just to give you an example, what's going to happen with these equations is they're still going to be the same, except that plus 5 is going to get added to the end. Same thing with this. You're going to get ax squared plus bx plus c plus 5 gets added to the end. And finally, the last one, because everything is shifting up by 5, we basically just say plus 5. Then the next thing is going down, like when it actually heads down. Let's say if this is minus 2, for example, then you repeat the same process. All right, what you're going to have is you're going to have the original function. I'm just going to write down all the original functions just because I'm freaking lazy at the moment. And all that's going to happen is minus 2, and minus 2. So next thing is, what do you do if both the vertex and the x-intercepts aren't whole numbers? Cubing, if they're not whole numbers, you can still calculate them. It's fine. It's numbers at the end of the day, mate. All right, now one other thing that I'm going to tell you guys is this. What happens when we actually move it to the left and right? So if I want to move the graph 3 units to the right, all right, and this is the part where you need to kind of keep an yeah, you could do the translations like that as well, so yeah, that's absolutely fine. No, because Daniel, the V is still going to be there because that's your original graph, and when you shift it by 5, you still have to keep that V there. The H and V that we talked about earlier is the vertex. Right there, because that is the vertex form right there. All right, so if you want to move 3 units to the right, just make sure that you can find wherever there's an x and replace it with x minus 3. So what I'm going to do is I've got a, x, and because there's an x there, I'm going to put a minus 3. The minus h is still going to stay there, plus v. And then if you look at it, if you got it from the graphics calculator, then you basically go a, because there's an x there, you're going to put minus 3 squared plus b times x minus 3 plus c. And then finally for the vertex form, you're going to do the same thing again. You're going to go a, x, because you see an x there, you're going to go x minus 3 and minus x1 times x. Because we've got an x there, we're going to put minus 3 minus x2. So basically when you're shifting to the right, you basically just chuck in a minus whatever you're shifting, you put that with x. So wherever there's an x, when you're shifting 3 units to the right, all the x's, you need to write minus 3. And likewise, it's the same. If you're going to the left side, and let's say you're going left side by, I don't know, 7 or something like that, what you're going to do is we're going to go a, and because we're going to the left side, just add, we've got to add it. So it becomes plus 7 minus h squared plus v. Just going to write this down first just because of the colors. So wherever there's an x, I'm just going to replace it with x plus 7. And pretty much the same thing for the last thing. So yeah, that's pretty much what you have to actually do in terms of translation. Yeah, I'm happy to give you guys a quick example. I'll actually leave this up here so that you guys can actually use this as a bit of a guide. So let's say we have a parabola, and I'll actually write it up as okay, and I want you guys to translate this 2 units to the right and 3, no, let's go 4 units down. So try this out while I give myself a little break. Leo, I'll get to reflections shortly, man. All right, so what I'm going to do is I will quickly put this up. So because it's actually moving 2 units to the right, what we're going to do is we're going to take wherever x is, we're going to subtract 2, and we got minus 5 squared plus 3, and because it's shifting down by 4, we're going to go minus 4. So when we simplify this, we are going to get 5x minus 7 squared minus 1. Yeah, so pretty much that's what we're looking at. I think, like, I'm gonna be honest, guys. Like, I want to try and do that last bit of excellence, not excellence, exponential questions, and then I'm basically done for this year for you guys. I just need a hell of a long break. Shaky, you be alright, man. Like, honestly, it's level 1. Just go in there, just do what you can, and yeah, you could actually just go through it. Trust me, you'll be fine. If you've done enough practice, then you should be all good. All right, cool. So we are going to go into our next next question, which is basically just quick. I did mention to Leo, he did talk about reflections. And it's probably easier to show this than actually kind of. Give me 1 second. I just need to find it. Where are we at? All right, so what we've got here is just going back to reflections. One of the things is this: if you want to reflect the parabola on the x-axis, all you have to change is just a minus in front of the y. Okay, because basically what that does is it should just reflect it on the x-axis. But if you were to change this, I think if you put this as minus, no, that ain't gonna work. Yeah, so that's basically what we're looking at in terms of, no, I want to get rid of this, hang on. So if you want to reflect on the x-axis, it's basically just get rid of the minus from the y on the other side. Then what happens is it just gets reflected on the x-axis. Guys, I'm honestly not sure what they have the pass marks for graphs, tables, equations, graphs, because yeah, I haven't had the chance to actually look at last year's properly. But reflecting on the y-axis, I think I might, like, what can we do? Let me show you guys another one. Like, let's just see, because I'm trying to think off the top of my head right now. It's like, so in this case, if I want to reflect it, it's changing the numbers inside there. So sorry, just give me a second. Then 4x squared plus 16. So if I change it to minus, yeah. So reflecting on the y-axis, I reckon this should actually work. All you have to do is just change the coefficient, just change the x, the symbol for the coefficient of x, and that should actually change the reflection on the y-axis. So if you notice, when it's plus, it's here. When it's minus, it's actually reflected on the y-axis. All right, so last bit of rundown for exponentials. And I thought, yeah, why not? Just pick the most scariest looking one and get it out of the way. So I'm actually going to leave this question here. Somebody actually asked before NAME. Let's have a look. Schedule. Oh yeah, I'm not me. I'm not sitting one. I'm good. So if you guys look at the paper, right, what they have basically said is, what do you get? So if you get one achieved question correct, you actually end up getting 3 marks. Yeah, 3 marks. So the way, and I know I probably should have actually talked to you guys about how the grading actually works. So in this case, an A3 is worth like one achieved question is worth 3 points. What about this one? 3 points, 9 points is what we're looking at. So basically, guys, to get an achieved in this paper from last year, you needed to answer 3 achieved questions correctly. Okay, so if you answer 3 achieved questions correctly, then you end up getting 9 points. Oxygen, I know I've seen that question pop up a couple of times, but like when the vertex is actually not given, they should give you intercepts. So you should be actually working with intercepts. Man on a mission, I've done so many word questions, man, on my tutorials and like the other exam papers. Right now, trying to find it is just going to be really tricky. Mahat Chowdhury, yeah, you're on the right track there, mate. Because even if we were to do it as, let me just show you, even if it looked like in vertex form, right? So say, for example, your graph looked like this, x minus 4 plus 2, for example. So if I change that minus to a plus, then that's going to reflect on the y-axis. Just changing that inside of it, it actually reflects. All right, so we are going to exponentials. Now, guys, what I'm going to show is this. Exponential from a table, exponential from a graph, it doesn't matter what they've actually done. When doing this, do you have to keep putting in the vertex after doing the strategy you did, or would it be correct as it stands? Oh, God, I can't even read that question. Amanda, I'm sorry. I'm going to come back. When doing the shifting of parabolas, do you have to keep putting in the vertex after doing the strategy you did? I don't know. I don't think I understand that question fully, Armand. Joy, that's a really tricky one, man. Like honestly, it just goes up and down. All right. When did the y-axis reflect? What I changed? Didn't see anything. So for the y-axis reflection, remember it is reflecting on the y-axis, which means like if your parabola is here, then it's going to shift over to here. So let me show you guys here that y-axis reflection. Right now, when it says x minus 4, the parabola is on the right-hand side. The y-axis is here. This is where the reflection is going to happen. So when I change it to plus, it's getting reflected on the other side of that y-axis. Sam, that's a really good question, and I want to show you guys real quickly the trick on that one. All right. So let's just go back to this for that reflection on the x-axis. So if you're trying to do reflection on the x-axis, come on, are you kidding me? worst time for the pen to actually run out of battery. No, we're good. False alarm. So, Sam, I think the question you asked me was this. If you have this equation here, and this is a little shortcut that I actually tell people, right? You want to reflect this on x-axis. Right? Yeah, you're right. You can actually put it as negative y equals this. But what you want to always write is you want to write your equation with y being itself. So what you could do is just rewrite this as y equals negative, like this, and that's absolutely fine. Quadruple A batteries. X and Y axis intercept form. X and Y axis intercept form is going to be pretty much the same idea again. So if I have this as, so if I want to reflect this on the Y axis, I just go and change that plus to a minus and plus to a minus, and that's just reflected it. And now if I want to reflect this on the Y axis, I can just put that negative in front of y there, and that just flips it. All right, mass. Enough of quadratics. We go to exponentials. All right. So guys, with exponentials, what I ended up seeing with exponentials is this: that getting the equation for an exponential graph. Where was it? Yeah, just getting the equation for the exponential graph, or even drawing it, last year was actually at a merit. So it's a really good idea to actually keep this in your, just knowing how to do this. I think I made a video ages ago about this particular one where I just made up a random formula, but this random formula does actually work. So what we're going to do is I'm going to go through exponential from a graph or a table. Because remember, if you're given a graph, then what you can do is from the graph, you can actually take some points, create a table, and then work out what the equation is. So the one I'm going to do is this one right here, which I know you guys can't see. How the hell am I going to put this out here? You know what? I'll just have to do a double switch soon. So just give me 1 second. I can't show you guys two screens. So let's say you get given a graph like this here. All right. Let's pretend that you can't actually see this stuff here. So let me just get rid of that. And you only need 3 or 4 points. All right. You don't need all these little points here. Someone asked me earlier, what is an asymptote? Now this right here, like this graph, is never going to touch the x-axis, and that's because it's an asymptote, right? So if we just zoom in there, like what you guys will see is that that line is never going to touch the x-axis, regardless of how far I go in the x-axis. So really, when you're dealing with exponentials, what you want to do is you want to grab 3 or 4 points. All right, that's a good start to go with. So here, if I look at it, my first point I'm going to choose is 0, 1. Now I'm just writing it down on the other page, and you guys will get to see it very shortly. But I'm just going to grab these numbers so I can actually create a table out of it. So I've got 0, 1. Then I've got -1, -1, and +2. And I've got -2 and +4. And I'm going to pick one more number, which is -3 and 8. All right, let's go back into my notes. Yep, so Alexander, we are doing that right now. So basically all I've done is I've taken the graph and I've taken down 4 points from that graph, and now I have to create an equation. Now, and look, I don't want to freak you guys out or anything like this, but the easiest one that's worked is this particular one that I've been working with. It's basically this one right here. Y equals ARX plus C. All right. The reason I use this particular formula is all the translations that you learned for parabolas works for this as well. Okay, so everything that we did for the parabolas just like about 10 minutes ago, it's going to work for the exponential ones as well. So ARX to the power of AR, and the R is like the X's in the power, plus C. Now, what we're going to do is we're going to have to do a little bit of simultaneous equations, but if you're lucky, you don't even need to do that, especially if you have the zero value. Things just become a lot more easier. And I've given you guys a bit of an easy one to kind of start off with anyway. So the first thing is to figure out what this is. The R stands for ratio. And I can already see people making that mistake. They've actually put down R is actually 2 in this case. It's not. Because look at the numbers. What's happening to the numbers? The numbers are actually getting divided by 2. They're not increasing by 2, they're actually halving. So the ratio in this case is you're actually multiplying these numbers by a half. So the ratio is actually, in this case, it's a half. Now that's another good thing to know. If your ratio is above 1, then you're going to get a graph that's actually going up. Our graph was actually going down as we headed towards x, as x tend to become big, right? The next thing is looking at this value right here. That one, when x equals to 0, y is equal to 1. So what we're going to do is we're going to substitute it in. So we're going to get 1 equals a half to the power of 0 plus c. So in this case, half to the power of 0 is just 1. So you're going to get this as a plus c. Now look guys, as I said to you, if you have learned this in a completely different way and you're happy with it, just stick to it. Because I'm going to be honest, this is like that just, if you're trying to learn this like pretty much the night before the exam, it's like might be seems a bit confusing, but it does work out. There are so many ways in which you're going to get an answer for this, but yeah, so we're going to leave this as one equation. Now we're going to take another equation. Our next equation we're going to take is -1 and +2. All right, now if you, like I said to you, if you already know how to do this in a different way, stick to it, because our answers in the end, they're going to be still the same. Amir, you pretty much follow the same thing I've done here with the table. You work out the R first. Once you work out the R, then you can actually use simultaneous equations to work out A and C. So here, I've got 2 equals A half to the power of -1 plus C. So now what I've got is, I've got to work out what half to the power of -1 is. So I'm just going to go to my calculator and put in a half to the power of -1. Now I've given you guys a tricky one to start off with, so that it actually makes sense later on. So this is my 2 equations. And at this point, I can just use substitution and just get my value for A and C, or I could just use my graphics calculator and put in simultaneous equations. All right, to use simultaneous equations, I guess I'm going to do this the long way, just so just so people can see the way of doing it. So that there is 2a plus c equals 2. That comes there, which is a plus c equals 1. Now, all I'm going to do is I'm going to subtract top minus bottom, top minus bottom, top minus bottom. So 2a minus a, so minus, minus, minus. 2a minus a is a, c minus c is 0, 2 minus 1 is 1. So my a value is 1. And because a plus c equals 1, 1 plus c equals 1, I can say that c is equal to 0. So there's actually no graphics calculator using this. You can just do it without it. And what you end up with is the equation as 1 times r, which is half, x plus 0. Now, other people might have got different variations of this, and that's absolutely fine as well. But the exponential, unfortunately, you cannot do it in a graphics calculator because it depends on where the asymptote is. And I've kind of been messing around with that for a while, and eventually doing it the classic way is the one that actually goes. What I'll do is I'll actually put up a link on the chat of just like a 20-minute video that goes through this in a bit more detail. I just gotta find it. Give me a second. Can't even find my own videos. God. Right, an exponential. Come on. Oh, there it is. Okay, so copy link. So honestly, guys, like if you, I know it can be a bit confusing, but that link that I've just put up there, that covers it in so much more detail, and it's only about 11 minutes. But trust me, you can get exponential graphs from that in no time. Even writing the ratios, you get the ratios, you will be good to go with a nice. This coming up with the equation of exponential ends up being like a merit easily. And then if you do any kind of translations, it ends up being excellence. Annika, so if they ask you guys to graph a particular graph, like how you put it up, so let's say graph 2 to the power of x minus 1, right? My thinking is this: get a little table, put down x and y, and put down 0, 1, 2, 3, and just start substituting it in your calculator. So go 2 to the power of 0 minus 1, and you get 0.5, and then basically just keep going. All right, what happens if you then get rid of 0? You get 1, and then you literally can do this for every x value. The other way you could do this is also, you could potentially just go table, where is table? Right there, and just put in your function. You can just go 2 to the power of x minus 1 and press enter, and see this little set. Click on it, you say start value is 0, 5, and then you just click on table, and that gives you all your tables. So once you have your tables, just plot those points, but make sure that you guys get a curve all the way to the end, but don't touch the asymptote. Like in this case, the 0 is the asymptote, so you don't want to be touching it. Cool. I will send that link again for the exponential one. But yeah, look, reflecting on the x-axis and the y-axis, pretty much the same idea, guys. So if you have like, let's actually go to the Desmos so we can actually show it to you guys. So if we have So you want to reflect this on the y-axis, then what we're going to have to do is, I don't know if this will work. Yeah, no, it's not going to work because I need to change this to y. So if I want to reflect this on the y-axis, I just change that to negative. If I want to reflect this on the x-axis, I change that to negative. Yeah, so those are the two things that, and translation works pretty much the same way. So if I want to move it up by 5, I just add 5 to the end. That moves the graph up by 5. If I want to move it, the graph 5 units to the right side, then I go, can I do it? -5. Oh, that's not letting me. Yeah, so what you can see is it's actually moved it 5 units to the right. So basically, exactly the same rules for translations for parabola, you can actually apply it for exponentials. How do you find the y-intercept? Put x equals to 0, Sophie. So Jackie, if you get given that graph, remember that your final answer could be written in multiple ways. So you can still get the graph converted to a table. Once you convert it to a table, you should be able to use that formula that I was talking about before to kind of help you with the getting the equation. Mahat, I think I've already done that exam paper, man, so all right, guys, look, that is basically a good hour there. Just wanted to say thank you for joining, and I know probably my intention was not to freak people out, but you know, sometimes it happens because they've actually seen something different. But all I can tell you is this: it's like go in tomorrow and just work out what you know. You know what you know. Just make sure you try and answer all of the questions that you can do. Reflecting the exponential equation, same rules as what we did for parabolas as well. All right, so exactly the same thing that we did in parabola. Like when it's shifting up, just increase at the, just add the number at the end. If it's going down, subtract, and so on. But yeah, I wish I had a bit more time to run tutorials this time around. But yeah, I've just been like really not well, and I'm just kind of glad that I can actually take a break. One more tutorial and I'm done. Yes, Andrew, thank you. Yeah, just reminder, guys, as I said at the start of the tutorial, make sure you change your calculators back to degrees after your calculator gets reset when they do the calculator checks. Renee, I think I'll do it tomorrow. But who is your teacher, Renee? No worries, guys. Look, all the 11s, I think you guys go get some rest, and yeah, good luck for tomorrow morning. It's a bit of a hard question to answer, Shiro. Yeah, good luck, guys. Go get some rest. I can't keep up. It's all right. You're welcome. You're welcome. See you guys next year at level 2. Ah, yeah, nah, Renee, I was there last year. Left to go across the road. Haven't met her yet. Yeah, no worries, guys. Look, go, as I said to you guys, I'm gonna actually probably clock out in a couple of minutes. You all should be getting some rest. And yep, don't forget the calculator reset. Change it back to degrees when you are after your calculator gets reset. Okay, you probably will have a house before, second house before I do, man. Now, I never did the 2017 and 2019. I just ran out of time in the end. Oh, thanks, little Kota. It's so nice of you to call me that. How do you reset to degrees? Just click on menu, go into run menu, just your normal run menu, click on shift setup and go down to angle and then click on F1 to change it to degrees. All right, so just shift setup, go down to angle and then change it to degrees. Harry, just once this is finished, it gets uploaded automatically. Just go have a look again, man. Jacqueline, it all depends on the question. So just read through the question and kind of imagine yourself in the situation and whether you will get it at the end of the hour or end of the day, or is it possible that you can get like, as I said to you that example, to figure it out is like I look at my pay. When I was working a part-time job, it's like if I work half an hour, I get paid for half an hour. If I work 20 minutes, I get paid for 20 minutes. So that part there is going to be like a straight line. All right. But if I look at my school, it doesn't matter how many hours I work, I'm still going to get the same pay. So that one is going to be like a flat line, regardless of how many hours I work. So it really depends on the situation. So you got to keep an eye on it and go. Just think about that situation before you actually start connecting all the dots straight away, whether it's a step graph or a straight line graph. Tim Tam, definitely not, man. Like it's not the end of the world. Like I think you guys and I know like coming from a Indian background, I know how stressful it can be with parents just putting so much pressure on exams and things like that. But understand this is level one, all right? It's not until like level two and it's not until level three that you actually get serious. So, use this as practice and then get back to work next year and the following year. Sorry, I just saw that. Now, look, I know. Now, I'm not gonna monetize, guys. It's just something that I've decided not to do. I might print some t-shirts for the hell of it, but not monetize. One thing that I'd say is this, when you guys get the paper, just read through it and actually spend the time there. You got 3 hours, you're in there. Just sit there and just work through that process, because sometimes going through that exam for 3 hours, it will actually help you mentally prepare in terms of how you want to approach these questions next year. Yeah, so I think, and I know like graphics calculator kind of helps, but the reality is that if you actually learn how to do this without a graphics calculator, it just tends to make things a lot more easy for you guys. Yeah, the whole monetize thing of I don't know, man. Like, my belief is that if you can help somebody, then just help. Don't expect anything back. Yeah, it's ironic I'm actually wearing this shirt. Like, see? I don't know if you guys can read this. Hang on, let's see. There we go. Probably can read it. Everything from comic books. Secunda, not now, man. I'm gonna go to sleep. Karanvir, translating across X and Y axis, man. It's right there. Look, where did we do this? There we go. That whole part. You know, you've been asking again and again, but that's what it is. That whole translation. Yeah, no, it's something that. Oh, Louis, good to see you, man. How's things? What has it been? Jeez, 2 years? Yeah, sorry, Louis. It's on slow mode because it's just nuts otherwise. The OneNote page, Aid, I think it's in the description of this video, or it definitely should be in this description of the video. I thought I said it. Please, yeah, definitely. The OneNote is actually there, called Notebook on the description of the video, and you can just go jump in and just have a look. Watson, he's awake. He's No, he's looking at me grumpy because he's trying to sleep. Yes, you can use highlighters in the exam, guys. Harry, after this morning's level 2 algebra, I don't want to even play that game. Uh, the indices rule. Arthur, I don't think you need to worry about it because like the exponential equation you can write in multiple formats. So which is why the ARX plus C will always work. Yeah, man. Geez, third year engineering. I didn't even realize. That's time is gone. I have to say I'm freaking absolutely enjoying myself at junior college, not having to worry about NCEA. The level 2 algebra wasn't like, I mean, like, I think I just saw like a couple of glimpses of it, but it's just a couple of questions were hard, but like rest of it was like, you know, the achieved guys will get achieved, the merit guys will get merit, the excellence guys, they've got to work hard. Eliana, make sure your calculator is in degrees for geometric reasoning. Didn't get time to do the 2017 papers, guys. Like, I'll be a little bit more organized next year. Yes, from Whanganui High School, yeah. Anyway, look, 10 o'clock, done. Go, go, go. You guys need rest. You got an exam in like 12 hours. I'm gonna sit and muck around and play games, but that's me. And yeah. So guys, as I said, good luck for tomorrow. Thank you again for joining and just all the well wishes and things. I will catch you guys next year for level 2s. Yeah, we'll just see how things go. And yeah, take care. I'll see you next year. Have a good Christmas break and everything. And let me know tomorrow how the exam paper actually went. See you guys. Yeah, Louis, catch you later, man. I'll come by for a visit. We'll have a chat. But I'll catch you guys later.